Welcome. Today, we are diving deep into the heart of where our physical world gets built, the engineering workshop. We're actually using a university lab manual as our guide to really understand the tools and the techniques that turn raw materials into pretty much everything around us.
I mean, really think about it. The chair you're on, the desk, the phone in your hand, everything goes through this amazing process of being shaped, cut, and joined together. It might seem super complex, but it's all built on just a few core principles. And those three things are what it's all about. That's what we're going to explore. We'll see how these massive machines give us the power, how super careful measurement creates precision, and how absolutely all of it is governed by a total commitment to safety.
All right, so here's our game plan. We're going to kick things off with the single most important rule in any workshop, period: safety. Then we'll get into the heavy stuff in the machine shop, zoom in on the incredible skill of metalworking by hand, and then wrap it all up by seeing how these ideas come together in the world of carpentry. First up, safety. Before a single machine is turned on, before any material gets cut, you have to create a safe space to work. I mean, all the power and creativity in the world don't mean a thing if you can't do the work without getting hurt. It's non-negotiable. This slide completely changes how you should think about tools. Before you even think about picking up a hammer or flipping a switch, your personal protective equipment, your PPE, is actually the first tool you use. Every single item here, from goggles to gloves, is designed to protect you from a very specific danger in the workshop. And this is why those rules are so critical. These simple little drawings show the very real consequences of cutting corners, using a screwdriver the wrong way and stabbing your hand, or welding a closed container and causing an explosion. See? Every single rule is there for a very, very good reason. Okay, now let's head over to the machine shop. This is where the real heavy lifting happens, where raw, incredible power is used to shape tough materials like steel in ways that would be totally impossible by hand.
Our first stop is the lathe. And honestly, the best way to wrap your head around it is to think of a potter's wheel, but for metal. The piece of metal you're working on spins like crazy, and you bring in a stationary cutting tool to just shave away material, creating these perfect cylindrical shapes.
And don't let that simple idea fool you. The lathe is an absolute workhorse. It's not just for making cylinders. You can use it to turn down to diameter, face off the end so it's perfectly flat, drill a hole right in the center, create those cool textured grips through a process called knurling, or even cut the threads for a screw, all in one machine.
Next up, we've got the milling machine. Now this one's kind of the opposite of a lathe. On a mill, the cutting tool is what spins, and the workpiece is held still on a table that you can move around. This is how you get those perfectly flat surfaces, cut slots, and make all sorts of complex shapes.
And of course, we got to talk about how these classic machines have leveled up. A CNC machine, that stands for computer numerical control, does the same job as a manual lathe, but it's all automated. A computer program tells it exactly what to do, which lets you get insane levels of precision and make parts that would be way too complex to even try by hand.
Okay, so we've seen the raw, brute force of the machines. But now, let's zoom way in, from the power to the precision. This is where human skill really takes over for all that fine metalworking.
And here's the thing you absolutely have to remember. All that machine power is totally useless without accuracy. Before you even think about making a cut, you have to measure and mark your material with absolute precision. And that's where hand tools are king.
So, first things first, you've got a simple problem to solve. How do you hold the thing you're working on steady? The answer, for centuries, has been the bench vise. It's such a basic but essential tool. It clamps your material right to the bench, so now both of your hands are free to do the detailed work.
Okay, this is a perfect example of where the details are everything. These two punches look almost identical, right? But the angle of the tip changes the whole game. The one with the sharper 60-degree point is a dot punch. You use that to mark out fine lines. The other one, with the wider 90-degree point, is a center punch. Its whole job is to make a little dimple in the metal to give your drill bit a perfect place to start so it doesn't slide around. Genius!
So what happens when you need to measure something a ruler just can't get to? Like the diameter of a pipe? That's where calipers come in. The outside calipers on the left hug the outside of a part. The inside calipers on the right expand to touch the inside walls. They're what you call indirect measuring tools, because you use them to grab a dimension, lock it in, and then you measure that distance with your ruler.
And now, we're taking a huge leap forward in accuracy with the vernier caliper. This thing is a work of art. It's got jaws for measuring the outside of things, another set for measuring the inside, and even this little blade that shoots out the end to measure depth, all in one tool. But the real magic is that sliding scale, which lets you get an incredibly precise reading right off the tool itself.
But if you need the absolute ultimate in precision, that's when you bring out the micrometer. Just by turning this little thimble, you can make tiny, tiny adjustments, letting you measure down to 1/100th of a millimeter. And see that little knob on the end? That's a ratchet. It clicks to make sure you're applying just the right amount of pressure every single time for a perfect, consistent measurement.
All right, for our last section, let's switch gears a bit. We're moving from metal to wood. Now, the material is totally different, but you're going to see that the big ideas, holding, measuring, cutting, and shaping, they're exactly the same. Welcome to the world of carpentry.
In woodworking, one of the real secrets is joinery, which is just a fancy word for how you connect two pieces of wood together. The strength, the look, the durability of whatever you're making, it all comes down to the kind of joint you choose.
Let's check out a great example, the lap joint. Now this is so clever. You actually remove half the thickness from each piece of wood right where they overlap. That way, they sit perfectly flush, and here's the key, you've created a much bigger surface area for the glue to grab onto, making it way stronger than just sticking the ends together.
And that brings us to what's really the pinnacle of the craft, the mortise and tenon joint. This is where you cut a little peg, the tenon, on one piece that fits perfectly into a hole, the mortise, on the other. It's incredibly strong, it looks beautiful, and it takes so much skill to get right. It's the perfect combination of precise measurement and accurate cutting. You know, the manual we've been using as our guide really sums it all up perfectly. The point of all this isn't to make you a master machinist by the end of it. It's to give you that bird's eye view so you understand the basic challenges and solutions, and so you can look at the whole world of things around you a little bit differently.
So we've gone from safety to raw power, from precision to pure craft. We've seen the fundamental building blocks of how we make, well, everything. And it all leads to one final thought. Once you understand how things are made, that's the first step to making things yourself. So what will you build?